Okay, so let's look at number 13. It says find a function f that the graph of f has a horizontal tangent. When you see horizontal tangent, you know that wherever it's at, the derivative is 0. Okay? Your at moment is x is equal to 3 and y is equal to 0. So a horizontal tangent on f says that f's position will be 0 at 3. 3 seconds, 3 hours, whatever the units of measure are for your input. We're given the f double prime. So you see we're going to have to go back 2 levels in order to get to f of x. Okay, so let's take the antiderivative one time. We get 8x. It is in respect to x. So remember, you're always having to write this down. I haven't said it yet in the video, but this is very important, just like units are. If you don't write this down on your setup, you'll lose a point on your quiz and or test every single time you don't write the dx. Because I want you to know when you're supposed to write it, and I want you to know when it disappears after you've taken the antiderivative. Alright, so those of you probably looking at this, constant multiple ruled out that 8. And what would the antiderivative of x be? Anybody? X squared over 2. We have to multiply by what? 8. The 8 by constant multiple rule. And then it's plus c because it is indefinite. This does reduce to a form of 4x squared plus c. And this is representing the one level jump up. Therefore now this is the first derivative's general solution. Okay? Okay, so we want to know, this is my at moment, okay? So at x is equal to 3, we could say the derivative at 3 is 0. Okay? Are you with me? This 0 that they're saying here, these are not the same zeros. They're not. This 3, 0 is a point on the graph. Let me highlight it in gray. This is a point on the graph. This 0 came from the fact that they said it was a horizontal tangent. Okay? So let me highlight that better because I just might have confused you. The horizontal tangent is where the derivative is 0. Okay? This 3, 0 over here that they gave us was on the position function, said at 3, 0 on the graph. So wherever that's at, 1, 2, 3, 0, there's going to be a point here that has a horizontal tangent. We're good? Okay, so we're going to plug this horizontal tangent equivalency here as 0 for the horizontal slope, and we're going to plug in what for x? Anybody? 3. Okay, that's your at moment. So you get 36 is, so c is what? Negative 36. So you plug this in to your general solution to make it more exact, to make it particular, okay? So that general solution is going to become what we know as f prime of x is equal to 4x squared minus 36. We're almost there. This isn't our answer, but we are almost there. We just have to take the antiderivative one more time. Okay. So if I take the antiderivative, I have 4x squared. I'm going to jump a couple steps now that you guys are in the groove of it. And then we're going to subtract 36. And that's it. So now we're going to take the antiderivatives of these. X squared becomes what? X cubed over 3. We're going to multiply this 4 back in. It's like 4 over 1, if you will. The antiderivative of 36 dx becomes what? 36x, and then plus c. Remember, this is representing that f of x because we took the antiderivative one more time. Alright, so now is where this position point highlighted in orange right here is going to be used on the position function. Okay, what am I going to put here as f of x? 0. I'm going to put 0 because that's my output. This 0 right here. And then what am I going to plug in everywhere where I see these x's? 3. So 3 will go here and 3 will go here. Okay, so 3 cubed is 27 divided by 3 is 9 is equal to 36 if you multiply it by 4. And then 3 is 18, 48. So 36 minus 48. Negative 12, right? So C is what? 12. So C is 12. We're going to plug this back in, and that's how we get, hold up, what did we do that, why did they get 72 and we got 12?
36 times 3 is
Oh, thank you. 108, what am I doing? 108. So that whenever you do that, they become a negative what?
negative 72.
There you go. Thank you, Robert. Negative 72. So C is 72. When you plug it back in, you get what they have right here for your position function.